Hello, Willard fifth graders. I wanted to review some of the matter content that you've been learning, and I wanted to talk about what we would be doing if we were in the science room. Hopefully you have had a chance to look at my videos on white powders and how we would be doing chemistry on those white powders, on that matter, but this is a review of that information. If you're a scientist and you're thinking about matter, well, you need to know how you can describe that matter. The first thing you can do to describe matter is to describe what are its physical properties. Another thing you can do is to describe what chemical changes happen when that matter is mixed with something, when it's mixed with something else. Physical properties include all the things that you can observe. It includes all the different ways that you can use your senses. What does it look like? What does it smell like? What does it feel like? And then, of course, in the science room, we never taste things, so we're not going to see what it tastes like. Physical properties also include describing whether something is a solid or a liquid or a gas, describing its phase of matter, solid, liquid, or gas. Describing the physical properties also means to describe what happens when you mix that matter with a liquid. Does it dissolve in the liquid? Now, to remind you, what dissolve means is that if you take matter and you put it into a liquid, if that material breaks down into tiny parts that you cannot see and that gets mixed in with the liquid, then yes, it has dissolved. For example, when I make my cup of hot tea in the morning, I take sugar and I put the sugar in my hot tea and I stir it up. The sugar gets mixed into the hot water. It breaks down into tiny molecules that we cannot see, and it's mixed in with the liquid. I haven't made anything new. It's still sugar. I can taste the sugar. It's sugar water. It's sweet. But it's mixed in with the liquid. Things that dissolve are soluble. So sugar is soluble in my cup of hot tea. When we think of chemical properties, what we're thinking about is when we mix something, when we take matter and it's mixed with another type of matter, does something new form? Atoms and molecules, atoms are rearranged to create something new. So there are clues you can look for when you are trying to find out if there has been a chemical change, if something new has been formed. The first clue is to look for a new phase of matter that is formed. When you were in second grade, we made volcanoes, and we made a model of a volcano, and we took vinegar and baking soda and mixed it. Vinegar is a liquid, baking soda is a solid. And if you remember, good old kitchen chemistry, if you mix vinegar and baking soda, bubbles form. Well, those bubbles are a gas. So that's a new phase of matter that is formed. A gas was formed from a solid and a liquid. A new phase of matter was formed. That is a chemical change. The chemical properties have been changed. A new type of matter has been formed. You can also look to see if heat is released, if something feels warm, or if heat is absorbed, if it starts to feel cold. One more clue is to see if a new color appears. In my white powder videos, I added iodine and I added phenolphthalein to the white powders. And sometimes the colors changed. The iodine's a yellow-brown color, and sometimes it changed to a blue. Phenolphthalein is clear, and sometimes it changed to pink. If something new forms and a new color appears, then some chemical change has happened. Now, after we think about physical properties and chemical properties, I would show you a whole bunch of different white powders. And you would run those tests. You would test the physical properties of the white powders. You would test the chemical properties of white powders. You would have baking soda, and you would examine it. You would have some powdered chalk and some cornstarch. You would have all these different powders. You'd have some salt, and you would find out what are the chemical and physical properties of them. When you test those white powders, you would test to see, did the white powder dissolve in water? Was it soluble in water? You would also test for chemical reactions. You would look to see when you mix that powder, which is a solid, with vinegar, which is a liquid, did it produce bubbles? Did it produce a gas? You would look to see, did the iodine change color? You'd look to see if the phenolphthalein changed color. And I made a video showing you all the different tests of the white powders and what happens when you dissolve them, when you add vinegar, when you add iodine, and when you add phenolphthalein. But then what I would do is I would give you an unknown. I'd give you a white powder and I would not tell you what it was. And you would have to run all those tests on it, and you'd have to see if you could figure out which one it was based on the tests you had already done. Now, identifying an unknown material is called forensic chemistry. And this is on like cop shows all the time. It happens in our community. It happens. It's on the news. Sometimes they report if there has been an unknown material that's found at a crime scene, or maybe it's been found. Maybe it's something that that people are wondering if something has been smuggled into the country, or if there was something in an envelope and we don't know what it is. Then forensic chemists will take a sample of the unknown material and they'll run chemical tests on it, and they will try and figure out what it is. Well, I would be asking you to be forensic chemists, and I would be asking you to write a CER. CER stands for Claim, Evidence, Reasoning. It is just a way of writing to organize your ideas, to organize your thoughts, to explain why you think something is the way it is. So for the white powders, if I'm asking you to write a CER, I'm going to be asking you to tell me what is that white powder and why do you know that that white powder is that in a CER. So a CER, the claim is your answer to a question. Sometimes it's an answer to your question because you're doing an investigation. In this particular case, I asked you a question. You're answering my question. I'm asking you, what is the white powder? And so you would write down what you think the white powder is. Say the white powder is whatever you think it is. And then the next thing you would do is list your evidence, your data. In these times, what I've done is I made a video of the unknown powder, and I show you what happens when I try to dissolve it, what happens when I add some iodine and some vinegar and some phenolphthalein, and that's your data. What happens to the unknown? Your reasoning then is your explanation. Why do you know you're right? What do you already know about each of those white powders to be able to say, see, my claim is correct? So when I tested the white powders and you got to see that, that was your evidence. So one thing I did was I tested the physical properties. I took the white powder and I put it in water and I stirred it up. And was it soluble in water? Well, when you watch the video, you can see that no, it was not soluble in water. It was still cloudy and it sort of settled down to the bottom. It did not dissolve. Then I did some tests for chemical reactions. So when I mixed the powder with vinegar, did it produce bubbles? Well, no. When I added vinegar, nothing happened. So no reaction. Did the iodine change color? Yes, the iodine did change from yellow to dark, dark blue. Did the phenolphthalein change color? No. So in your evidence, you would write, the white powder did not dissolve. Vinegar did not produce bubbles when added to the white powder. Iodine did change color when added to the white powder. Phenolphthalein did not change color when added to the white powder. That's it. That's your evidence. That's what you saw happen when I tested the white powder. Then you write your reasoning. Your reasoning is your explanation for why your claim is correct. Well, you have to basically go through everything you know about all the other powders and then decide, well, what does that eliminate? What does that mean it could be? So part of your evidence was that it did not dissolve in water. So your reasoning would be, well, baking soda and salt do dissolve in water. Since the unknown did not dissolve in water, it cannot be either of those. So Crosses off the baking soda, that's not it. Crosses off the salt, that's not it. Then, chalk and cornstarch, turn iodine dark blue. You know that from the video I showed you about how different powders react. Your evidence was that the unknown turned dark blue. So chalk and cornstarch turn iodine dark blue. Because the unknown turned dark blue, it must be one of those two. Well, I can't eliminate any more right now. So what's another test? The phenolphthalein. Well, phenolphthalein will turn pink when it is added to baking soda. Since the unknown did not turn pink, it cannot be baking soda. Well, we already knew that, so that doesn't eliminate any more. And then what else other test did we do? We did the vinegar. Well, baking soda and chalk bubble when vinegar is added. Since the unknown did not bubble, it cannot be the chalk. So we cross off the chalk. Therefore, it has to be the cornstarch. There's your reasoning. So you've combined what you already knew from my video showing you how white powders react. You've combined that with your evidence, with what you know about how the unknown white powder did react. The combination of those two, that's your reasoning. So now what I've done is I've made another video of a different unknown. So I'm calling it very unimaginatively, I'm calling it unknown white powder number 2. So I'm challenging you now to watch the video for the unknown powder number 2. And I want you to figure out what white powder it is. You might need to go back and re-watch my first video on the different white powders and how they react to different tests. I want you to write a claim, evidence, reasoning identifying what this new number 2 unknown white powder is. I cannot wait to read what your answers are. I'll see you next time.